Hey kids, Mr. O'Brien here, and today I'm going to be talking about acids and bases. So last time we were together, I introduced you to 4 types of chemical reactions. Synthesis reactions, decomposition reactions, single replacement reactions, and double replacement reactions. And then I introduced a 5th type called combustion reactions. So today we're going to be talking about a 6th type of reaction called an acid and base neutralization reaction. But acids and bases are really important in our lives. We use these things all the time because they're really good at doing a couple of things in particular. You'll probably recognize these things in regular household chemicals all around the house. For instance, some acids. Well, what exactly are they? Number 1, they can break down metals. A lot of times if you put metal in an acid, you're gonna see bubbles start to form almost immediately. It's gonna start to break it down. Some examples of some acids that you might recognize would be some lemon juice. Okay, another property of acids are that they taste really sour. So the citric acid, which is a type of acid in this lemon, that's what gives it that really sour flavor. Or the tartaric acid in Sour Patch candies makes them taste really sour too. Another example of a sour tasting acid would be acetic acid, which you probably know as vinegar, okay? Again, really useful chemical that you probably have in your house right now. And then I've also got some very strong acid here called hydrochloric acid. You probably don't have any of this stuff in your house. This is a really strong acid, and you got to be careful with that. That's again why I'm wearing this eye protection and also safety goggles, because like we said, acids are corrosive. They can break down your skin, and they can even eat away some metals. So I wanted to show you guys an example of this happening. So I took a piece of aluminum foil, and I took a couple drops of this hydrochloric acid, and I dropped it rather, onto the tinfoil. And you can see where it created a burn mark while it started to kind of corrode and eat away that metal. And I said, you know, I'll still show it to the kids. I don't know if they'll be that impressed by it. But then I realized that I had actually folded the paper in half here, and the acid had actually eaten through this top layer down in between the 2 layers where it had kept going. And so you can see this thing is just still eating this metal away. You can actually almost, you probably can't get this in the video, but I can actually see through the aluminum foil in a couple of places here. Next thing that we're going to be talking a little bit about are bases. Okay, these are also found in your home in a bunch of different substances. So for instance, bleach is a base, okay? A lot of bases are found in cleaning supplies. And the reason for this is because they're really good at kind of breaking down certain chemicals. For instance, sometimes dirt and grease. Actually, it can even break down the fat on your fingers and in your skin. So it actually feels slippery if you get this stuff on your fingertips, because it's actually starting to break down some of those fats. That's also why it's used in soap making as well. So bleach would be an example of a base. Also sodium hydroxide, I'm going to be using this along with my hydrochloric acid in a little bit for a demonstration. And another common base would be baking soda. So for those of you who are mixing our acetic acid vinegar with our base, baking soda here as your everyday chemical reactions video, pay attention, because we're going to talk about a similar reaction in just a moment. So when chemists talk about acids and bases, we use something called the pH scale. Okay, the P stands for potential, H stands for hydrogen, and I'll talk about why that is in just a minute. But again, it's important that we have this system for kind of rating things as either very acidic or very basic or somewhere in the middle. And we use this scale called the pH scale. Okay. So right in the middle of that scale, it runs from 1 to 14. So right in the middle, we've got number 7. Okay, this is neutral substances, things that are neither basic nor acidic. So a great example of that is just pure water, pure H2O. Okay, that's neutral. It's neither basic nor acidic. It falls right down there in the middle. Okay, then on the low side of the scale, okay, so sometimes kids mix this up. They think the more acidic it is, the higher number it is. Actually, the more acidic something is, the lower number it is. Okay, so things way down here in like the 1 and 2 range, we've got like stomach acids and lemon juice. Hydrochloric acid would fall in here. And then as we work our way towards neutrality, we would have some other fruit juices, black coffee, some soda. That's why it kind of breaks down the enamel in your teeth over time. And then eventually we would get our way back to 7, okay, that neutral substance of pure water. On the other side, as we move up the pH scale, okay, then we're moving towards things that are more basic, okay, more basic. So again, this includes a lot of household cleaning products like bleach, ammonia, Windex and glass cleaner, and then slightly less basic things like hand soap, baking soda, and eggs. So again, over here, down on the low end of the scale, we've got our acids, and then up here at the high end of the scale, we've got our bases here. Actually, maybe I should use red down here for acid. Okay, so what happens exactly if we mix both an acid and a base together? Okay, my HCl is going to separate. Okay, so I'm going to end up with positively charged hydrogen ions and negatively charged chlorine ions. Okay, these guys are going to be now just kind of floating around in that water, and I'm going to do this actually in just a second here. Okay, that if I take this base, sodium hydroxide, and I mix that in some water, I'm going to end up with some sodium ions that are positively charged. And I'm going to end up with some negatively charged hydroxide ions. Okay, well, it looks to me like we've got all of the ingredients here to make some more molecules of water. I've got some H right here that's positively charged, and I've got some OH here that's negatively charged. Okay, so if those two things kind of come together here, okay, let's go ahead and highlight this so you guys can see here. Okay, I'm going to take basically the H's from my hydrochloric acid, and I'm going to combine those with the OH's from my sodium hydroxide. And what that's going to produce in the process is water. Okay, I've got H, and I've got H, and I've got O, which means I've got H2O. In addition to that, okay, I'm also going to produce another substance here. Okay, I'm going to be taking now my anion of chloride. Okay, I'm going to be mixing that with my cation of sodium. And as a result of that, I'm going to be producing sodium chloride or salt. So essentially what I've done here is I've made salt water. I've taken a strong acid and a strong base, and I've produced just pure water and a salt as a result of that. Okay, so I've taken my acid and my base and I've neutralized them. Okay, they're no longer going to be able to eat away metal or dissolve the fat on my skin or anything nasty like that. We've just got good old plain salt water as a result of this. So again, that's why we call these things neutralization reactions. Now, I do want to mention here, okay, we're always in one of these reactions, we are always going to be producing water as one of our products, and then we're also going to be producing a salt. Okay, now in this example, it was sodium chloride. Okay, one other thing I want to mention here is that this is a kind of subclass of double replacement reactions. Okay, if you take a look at this, I can kind of pretty much say that, if I wanted to, that this hydrogen is my A. Okay, this chlorine is my B. This sodium is my C, and this hydroxide is my D, okay? And what we've done is we've taken these guys, they've changed partners. Okay, now my hydrogen is present in my water along with my OH. Okay, that would be AD. And now I've got sodium present in my sodium chloride along with chlorine, okay, to make CB. Again, so this is an example of one of those double replacement actions where we took AB plus CD to produce AD plus CB. All right, so the last thing I want to show you guys today is what one of these neutralization reactions actually looks like when it takes place. This stuff is called litmus paper, okay? You've probably seen it before if you've got like a pool or a hot tub that you have to check the pH of. But there's a chemical that coats this stuff that changes colors when it's in the presence of either those hydrogen ions in the case of an acid or those hydroxide ions in the case of a base. So I'm just going to go ahead and I'm going to put a little bit of acid right on the tip of this paper here. I don't have quite enough there. Okay. And you guys are immediately going to see how it's turning that bright, almost pink magenta. Okay, so when it turns that kind of red or pink color, that's a dead giveaway that you've got an acid on your hands. Okay. On the flip side, if I use my base, okay, my sodium hydroxide, it's going to change a different color when it detects the presence of those hydroxide ions. Okay, so if I put this in the presence of my base, okay, you can see it's turning more of like a dark kind of purple, almost like a brownish color. And when you buy this litmus paper, it comes with a little kind of color key so you can actually compare the color of your paper here to see exactly what pH the substance is that you're testing. All right, so I've got a similar chemical present in this beaker, okay? This is called bromothymol blue. I've used it in a couple demonstrations throughout the year, but this is a nice, beautiful blue color when it's neutral. So right now this bromo blue is just mixed into some regular tap water. This is a nice neutral solution, okay? But if it becomes acidic, it's going to change colors, okay? So to demonstrate this, I'm just going to add some of that hydrochloric acid to our beaker here, and you should start to see let me do this with my white background here so you can see the color change taking place. Okay, so again, the fact that it's gone from blue and has now become yellow is letting me know that I've got a bunch of hydrogen ions in here. That hydrogen and that chlorine, that HCl, they've split apart. I've got hydrogen ions present. I've got an acid on my hands. Okay, but if I add my base, okay, my sodium hydroxide now, I'm going to introduce a bunch of those OH ions. They're going to combine with the hydrogen ions in here, producing water. And my sodium and my chlorine are going to mix together to form salt. Okay, and again, we should see a color change occur as this takes place. And it's gone back to that blue, indicating that it is now neutral again. So we took what was an incredibly strong acid, we took a strong base, we combined them, and in the process, we made salt water, okay? I'm not gonna drink this. You're just gonna have to take my word for it. All right, guys, thanks for listening. We'll see you next time.